So good afternoon. My name is Casimiro Vizzini from the Division of Science Policy and Capacity Building in UNESCO headquarters in Paris. And I'm the organizer of this session on sharing data. I have the pleasure to introduce to you the moderator of this session, Ernesto Fernandez Polcuch, that is the chief of the section on science policy and partnerships in UNESCO. Ernesto.
Thank you, Casimiro. I hope this is a continuous event. No, we didn't have really a stop over lunch. So thank you very much for being here. Thank you. As UNESCO, we organized this session, and we're very thankful to AAAS first, and to the panelists who accepted to join us in this session. The session starts with the idea of sharing data, and there I just wanted to make sometimes to frame it properly into this conference today. On one hand, we have the idea of sharing, and in particular, from the UNESCO point of view, in a multilateral sense. Rada already this morning talked about multilateralism, but from the UN, from the point of view of a UN specialized agency, we have been. This session is more about multilateral science diplomacy, and in that sense, it's rather different from most of what we've seen this morning. I missed one of the parallel sessions, but we have basically listened and discussed bilateral science diplomacy issues with different approaches on different areas, but this one is a little bit more about multilateral science diplomacy. And in that sense, multilateral science diplomacy is a very old. It's very old for us. We are at UNESCO. We're 70 years last year, and we've been doing multilateral science diplomacy since then, since 1945. But we don't see the current approach to science diplomacy only in terms of the big science multilateralism of the CERN that was established also under the auspices of UNESCO, or under the initiative of UNESCO rather, or the current establishment of Sesame, the synchrotron light in the Middle East that joins Palestinian, Israeli, Jordanian, and scientists from many different countries. That's like more of our standard way of looking at science diplomacy, but we are now facing different challenges in terms of multilateralism, and also multilateralism is back to some extent in a higher level of the diplomacy agenda than it was maybe 10 years ago. With the SDGs, the Sustainable Development Goals, this was mentioned already today, having been approved in September last year, and the outcome of the COP21, of the Climate Change Convention, the Conference of the Parties, rather, science and science diplomacy have taken a different twist, which I believe, and we were discussing, doesn't properly fit into the 20, or looks at it differently than the 2010 paper we always refer to, in terms of that we see a diplomacy fed, or where science fits into diplomacy, science in diplomacy, where the COP21 or the SDGs, the COP21 outcome or the SDGs are produced. So there is a lot of input from the science community towards those goals, but then those goals are global. Those goals are not anymore national. So they, once they established, kind of have an impact on science in the countries. We are seeing many countries rearranging their scientific system towards the SDGs, and this was shown today on the climate change line. Science changes based on a diplomatic agreement. So it's something like science diplomacy for policy. I'm trying to find out really what this means and how we frame this into the science diplomacy paradigm. So the other part of the sharing data is the data. The data issue was also mentioned by the keynote speaker this morning. She mentioned the industrial Internet of Things. She mentioned citizen science initiatives. And now in this session, we will move to discussing a number of particular issues related to data, to sharing data, to using data, big databases for science and for diplomacy and basically for development. Some of them are natural resources related, some of them are more health related, and our first panelist will talk about a health related challenge that is dealt with the Human Variome Program. But all these programs that we will discuss today also share in common that they are very closely linked to UNESCO. The panelists that will join today are part of the UNESCO family, as we call it. They are part of programs like more than programs, the Intergovernmental Oceanic Commission, the International Hydrological Program, the Human Variome Program, so all programs that are part of the UNESCO family. And today we were all discussing this morning about how complicated it is to deal with one different country in a bilateral conversation. The case of Brazil was brought up. Well, we deal almost every day with 195 countries plus 8 observers. So all these challenges of relating to other countries are embedded into our programs. And this is another item of science diplomacy in the multilateral sense that changes the way and the approaches. We need to look at things that are to some extent normalized globally, and at the same time, they are relevant at the national level and have an impact at the national level. That challenge, I think, will be given examples on by the panelists. So just briefly, let me introduce Dr. Lederer, Carsten Lederer. He's a researcher at the Department of Molecular Genetics Thalassemia at the Cyprus Institute for Neurology and Genetics. He's also a lecturer and course coordinator at the Cyprus School for Molecular Medicines. He received his MSc from the Friedrich Wilhelm University in Bonn and his PhD from the University of East Anglia for work in plant virology and in various laboratories. So, but he's now working on the, sorry, I'm trying to skip, but basically, he heads the gene therapy and genome editing group of the molecular genetics group in Cyprus. He will be much better in introducing himself. For me, this is a lot of difficult words, so please, Carsten.
I wrote this to trip you up.
It was a trap. Yeah, I fell into it. So thank you, and Carsten, the floor is yours.
Okay, thank you. Hiya. Let's find this. Okay, so thank you for being here, and I have the opportunity of talking to you by this conference organized by AAAS. Thank you to them for organizing this, and also to Ernesto and Casimiro for making the session possible. I have a window of time now after your lunch when you're still awake and haven't fallen into a digestive slumber, so I'll try to use this until my fellow speakers come on. They're going to have an easier time in a way because everyone knows that water and disaster prevention are really important for you. I'll try to convince you over the next couple of slides that actually hemoglobinopathies are also a global challenge that needs to be addressed. You can hear me when I'm that far back, right? It's not a problem. Okay. So I'll just put this bridge on here to remind you where I'm from geographically now, which is Cyprus. It's a Venetian bridge, which is fairly far away from Venice in Cyprus. And it indicates that Cyprus has a lot of history, and much of this history has been shaped by hemoglobinopathies. They're related to hemoglobin, of course, which is the red pigment in your blood that binds oxygen and supports your body with oxygen and that transports carbon dioxide back. Incidentally, how many of you are biologists or have a biology background? Whoa, okay, good. Oh, that's unexpected. Okay, so So actually, if you look at your blood, 95% of your red blood cells, if you dry them out, are hemoglobin. So hemoglobin really determines the survival and the shape and development of your red blood cells. If there are defects in hemoglobin, then we have what are called hemoglobin disorders. These defects might either be absence or reduced amounts of hemoglobin, those are the thalassemias, or structural problems, abnormal hemoglobins, which, for example, would be sickle cell disease. Now, the severest forms are actually lethal in the womb, so you wouldn't even be born with some of those forms. Others are lethal early on during your development, so in the first decade of life. And these are normally dealt with, although there are curative approaches like bone marrow transplantation. Hemoglobinopathies are normally dealt with by chronic blood transfusions, either every 2 weeks, every 4 weeks, or maybe longer apart, depending on the severity of the disease. You need expensive medication, and some of this medication is extremely expensive, for example, for the removal of the toxic iron that accumulates when those cells die. And to provide all of this, you need the corresponding infrastructure, because otherwise compliance of the patients will be low and there will be premature death, and also the blood supply, which is critical and is a critical link in disease management, will not be safeguarded. Most common amongst hemoglobinopathies, and they're called the major hemoglobinopathies, are sickle cell disease and thalassemia. I'll refer to them as SCD and THAL in the following slides. So I probably still haven't convinced you that hemoglobinopathies are important, not as important as water and disasters. But if we look at the epidemiology of these diseases, they're closely linked traditionally to malaria regions because they confer resistance to malaria. So in regions of malaria, historically, people who were carriers for hemoglobinopathies had greater survival and reproduced more. So there's a high level of enrichment for hemoglobinopathies in those areas. Now, by now, many of these areas do not see malaria anymore. For example, in the southern United States, malaria has been eradicated as well as in much of northern Europe. But where malaria goes, the genetic disease still stays behind. Okay? So that now we have an annual birth of around 300,000 babies affected with major hemoglobinopathies, most of these in Africa and suffering from sickle cell disease. Because of the low level of infrastructure there, 50 to 80% of children actually die before they reach the age of 5. So it's quite a severe impact on the population there. 55,000 approximately of those births are thalassemia and are more localized in the Western Pacific, in the Eastern Mediterranean, where I am now, and in Southeast Asia. So globally, we've got 20 million sickle cell disease patients now and over 100,000 thalassemia patients. You'll tell me that still isn't that relevant, for example, for the United States, or if you're of Anglo-Saxon background generally, because also in Northern Europe there was never any significant malaria. But then migration steps in, and epidemiological trends make hemoglobinopathies a global challenge, as the WHO called it, because there's increasing migration, and in particular globally increasing migration from so-called source countries where hemoglobinopathies are endemic to sink countries like the United States or like many countries of Northern Europe. So this brings about new challenges, for example, for the USA and for the UK for sickle cell disease. What we have here is a picture of 1960, and we see here India as a major source country, mainly with migration to the sink country of Pakistan, but also to the United States, for instance. The Republic of Congo and Nigeria also as source countries. If we move on 40 years, actually this has changed enormously. Now Australia, also Northern Europe, and in particular the United States and Canada are major sink countries. So there's an immigration of patients and of carriers of the disease. And if I put a lens on this for the USA and for the UK as a temporal development, then we see there's not only an increase of migration to those countries, and the US in particular has always been an immigration country, but then we see there's a widening gap between the level of immigration and the level of immigration of sickle cell disease, that's HBS, patients. So there are more immigrants, and these immigrants, a larger proportion of them actually has the disease. What is of significance here is also that for the UK, for instance, there's a limited program of disease prevention targeted to ethnic groups of high risk. so that the level of uncertainty indicated through these shaded areas is very low in the UK. So there is a good level of data-guided policy on health prevention and disease provision, whereas in the United States, there's also a high level of illegal immigration, of course, which is not monitored for mutations. Health planning is difficult, so there's a high level of uncertainty. Now, besides this immigration issue, there's also an increase of life expectancy, which has been a major achievement over the last 20 to 30 years medically. And if we look, for example, at numbers available for Italy and focus in on births apart by 10 years between 1960 to 1964 and 1970 to 1974, within this 10-year period, the proportion of patients that survive more than 25 years has more than doubled. Okay, so there's a significant increase of the patient life, and what, for example, is happening now in Cyprus, where previously thalassaemic women could not have babies because it puts a huge strain on the system with the additional blood supply that is required. Thalassaemic women actually have more babies than healthy women. Maybe they want to show society that they can do it, but basically medical supply and disease management are very good now. So these patients survive longer. That also means, however, that they cost more. Okay, if we look at concrete numbers here, without wanting to bore you about this, we have a cost annually for hemoglobinopathy patients of between $64,000 to $14,000 per year. And this adds up for the United States, which has a huge population of sickle cell disease patients from the Afro-American community, to $1.1 billion per year. Okay, that's money, of course, that cannot be spent on other health expenditures. Okay. What adds to this is that this is not stable, besides the immigration issue and the extension of life, because also medication becomes more expensive. If you look at the extrapolation here, over the next 6 years, health expenditure of these different items that relate to disease management will double in the United States for sickle cell disease. Okay, so maybe by this time I've convinced you that it is a relevant problem, also for the US, but actually globally. If we look at the Syrian refugee crisis as a topical example now, and we can do some back-of-the-envelope calculations for extrapolations of this development, then Syria in 2009 had 8,000 thalassemia patients with an estimated increase of 10% per year because there was no screening program. These are all rough estimates. And heaven knows what has happened in the last 5 years after all mayhem has broken loose. There was an estimated carrier rate of 5%. So with this you can calculate that 2 carriers might marry at a likelihood of 0.25%. Okay, and each child of them has a likelihood of about a quarter of being thalassemic. Okay, all of this is a bit boring, but basically what this means for Germany, where over the last year there were about 500,000 immigrants from Syria alone, it means that over the next couple of years they will expect at least 150 new thalassemia patients, which you can calculate from the odds. This is based on assuming that these couples will marry amongst one another, and that's a critical and probably flaw in this, that these couples will only have one child. Okay, so they're likely going to have more children, so that I think that over the next 5 years or so, thalassemia numbers in Cyprus in Germany might double because of this. Okay, there's a war in Syria, but why do they not stay around Syria in neighboring countries? Because one of the 4 major reasons of departure into SINC countries further apart is the shortfall of medical aid. For Jordan, we have numbers where over the last 2 years, the number of chronic patients for whom no health provision can be provided has doubled and almost tripled. UNHCR has agreed on international criteria for resettlement, and one of those criteria is serious medical conditions. So there will be an increase of patients moving to SINC countries. And if I were a parent of a thalassemic child, which would probably die over the next 12 months without medical provision, I would get on that boat, or I would jump the picket lines to get elsewhere where my child is provided for. This means that at any rate, the immigrant refugee population will have a higher than average rate of hemoglobinopathy carriers. Okay, so this requires a local disease control, and if local disease control is put in place, then you end up with a picture like here for Cyprus or for some of the other countries where prevention programs are in place, where you have a vastly reduced number of births compared to expected, which would be the 100% line. Okay? To achieve this, you need first 2 steps. As part of the removal of obstacles, you need to establish working relationships to teach those people. And if you want to discuss these later on, that's fine. Okay, I just need to go to this. And what is of interest, we can always return, and I've numbered the slides as well, so it's easier to go back. And the second step is then to identify, in collaboration, the local needs in those countries, both educationally and also infrastructurally. The next step then is to establish autonomy in those countries. That is for disease prevention, disease management, and education of the patients and of clinicians and decision makers. Okay? Because many of the expectations of patients are unrealistic of going elsewhere, and awareness of what they have the right to locally is also not there. Now, it turns out, if you sit down rationally and think about these things, actually shared databases are a perfect way of achieving all of these things. We haven't thought about this. We actually learned this over the last 10 years. So it's kind of developed out of our laboratory work because we're involved in diagnosis. Shared databases in this context are a means and an end at the same time. They're a means because they forge links for collaboration. They actually symbolize the commonalities within a region because you then find out that many of the mutations that you have, in our case, for example, are shared between different nations. They are highly affordable if you compare them to other biomedical endeavors you might indulge in, because what you need is a good computer and some bioinformatics stuff. And they avoid many of the bioethics hurdles that are tied up with other biomedical projects. And that looks a bit trivial from where I stand now, but many times when you start collaborations, bioethics committees and these kinds of agreements are major impediments to progress. Now, those were the means, but of course, databases are an end in their own right because they give a tangible benefit to the clinicians and researchers. They are an asset for future collaboration because they attract further money because funding agencies trust in you if you already have established a database. And they deepen and widen the collaboration in the future because you can add additional database fields or additional collaborators. Now, when we set out to do this, it was the Ethernet project 10 years ago. And this was under the European Union Framework Program 6. And at the time, it was an amazingly ambitious program because it involved 26 organizations from 16 countries, which are depicted here. And if you include countries like Tunisia, Egypt, Israel, the Lebanon, Cyprus, Greece and Turkey, you don't only have vast problems in combining those different infrastructures, you also have interesting dinner conversations that might be slightly unscientific. So the establishment of Ethernet also led to the establishment of collaborations that still exist, and they gave us a track record of database development. While because of these problems of inexperience of the collaborators, actually the database did not have substantial addition to its content at the time. We actually identified the key challenges that were involved in these collaborations, and we identified the universal needs that these databases would have for the clinicians and the researchers. Specifically, you need a user-friendly interface because clinicians tend not to be very tech-savvy. You need to have a comprehensive mutation database that also covers modifiers of the disease to allow diagnosis and disease prediction. Clinicians are highly interested in genotype-phenotype correlation, so they can counsel couples, and they can say, if you have a child, it will be this severely affected, which then gives the couple a choice about their pregnancy. And it also includes epidemiological data, which are important for data-guided policy making. Okay. Now, the next step up was basically an internal project through Cypriot funding to populate the database with data, to refine the interface and to make it ready for the public. You might, in database terms, you might liken this to the training phase of Rocky Balboa for his big fight. So basically, in the dark, we were kind of adding data to the database. We dealt with our clinicians and made many things clear that are still not clear because clinicians never agree on certain terms, but you just have to find a consensus that you put in the database. We added official descriptors, maps for epidemiology, and also text content to increase web traffic and make this portal and the database more attractive also to non-bioinformatics people. Okay. Now this Establishment of the portal actually then attracted additional funding, like the Thalamus project and another Cypriot project for further data additions, again of functional data and of diagnostic images that would help a clinician in making a diagnosis after analysis, involving all of these countries, which already shows that having a database actually is like having a big fishing net that becomes larger when you throw it out. It's easier to attract further collaborations and to actually grow the database. Now the database looks like this now. So the portal as an interface has different sections, also including specific project sections and so on. But the databases, for example, hold information for genes and for mutations. The different genes and regions are here, and if you click on these, and there are numerous entries for each one of these, you get a list, for example, sorted by the gene affected. Now, for the non-biologists, that's all a bit Chinese now, but I'll just show you the potential of this. It's easily searchable, so it's easy also for my son to look something up there. So it's an easy interface. And if you then choose one of these specific mutations, like here for sickle cell disease, it gives you relevant information for the sequence, for related data and links, and it also gives you the context within the NIH-maintained NCBI sequence database, which is fetched real time, so it's always up to date. And if you have a sequence, for example, for a particular patient, you can immediately see if the mutation you have detected might be predicted to be causative of hemoglobinopathies. Okay. Under development, because it's currently only at the country level, but we now implement it for regional levels as well, are the maps for frequencies. And there's still a couple of hundred articles missing that we need to enter here, but content development is underway to make this also a tool for anyone interested in epidemiology and in health planning for a region. Now, in steps the Human Variome project, which is a project of 81 countries, which involves more than 1,100 people involved in science, medicine, and also in diplomacy, as it turns out. So they want to foster collaborations around genomic data and the sharing and harmonization of those data. And they do this by two key mechanisms. One is by supporting groups that develop disease-specific databases like our own. And they do this also by supporting national capacity building, which means enabling countries to implement genomic and diagnostic projects. Okay. Now, part of this now is the Globalglobin 2020 challenge, which squarely tackles hemoglobinopathies. This was launched in 2015 and is a sister project of the, let's call it, First World Breast Cancer Challenge, which is based around countries that already have a good infrastructure and already existing databases. The project, the Globalglobin one, is coordinated by HVP from Australia, by Helen Robinson. Project leaders are in South Africa and Malaysia. It's Professor Raj Rameshar and Professor Falil from Malaysia. And they're interested mainly in low and middle income countries, with Cyprus as one of the poster boys for disease prevention, to target hemoglobinopathies. Okay? And a key aim is to build capacity for genomic analysis, but of course downstream from this is the enabling of those countries to perform disease prevention and disease treatment. Now, it's a nascent consortium with a large number of countries already involved, and there's a forthcoming UNESCO in Paris meeting at the end of May, where there's already more countries that have indicated on this map, so that's already outdated. We're coordinated from Australia, but there's no contributing clinician from Australia. And also we've got members involved from the States, but no clinicians yet, so any applications are welcome. Okay. So the GG 2020 challenge has now integrated the Leiden Open Variant database. If you are involved in biological databases, you will know this interface. Basically, it's a widely used for actually dozens to hundreds of different databases interface that will be familiar to anyone using bioinformatics tools and also to anyone who's used another LOVD-based database. So this will encourage new contributions, okay? And it'll also prepare participants of the portal it'll enable them to also contribute to other databases that are based on the same interface. What I show you here is what this implementation is trying to avoid, and that is related to one of the posters, I think it's Igor Linkov, if I get the name right, outside, about networking. If you have initial collaboration between two partners, if you go on adding further collaborations to this, normally the internal ones are strengthened and they will have most collaborators. That's not really what we want in Globalglobin. We want new editions not to be disadvantaged and to be just as central and important as the first editions to this network. And to have a familiar database will help with this. Now, GG 2020 is endorsed by UNESCO and the WHO because of its goals overlapping with their goals, and that is to achieve best practice of variant data saving, the contribution of low and middle income countries to international databases, and then stretching HVP out of its comfort zone. It's to establish local health services in countries involved and to have sustainability of this by stakeholders being involved internationally. Now this exactly fits with what I told you about the necessity to achieve local disease control, which is the removal of obstacles to progress and to establish autonomy locally. A short example, do I still have time? I don't know how I'm doing for time, Ernesto, sorry.
Yeah.
Okay.
I also don't know.
Okay, so one of the examples that are within Globalglobin.
3 more minutes.
Cool, let's go. Okay, so one of the examples within Globalglobin 2020, and there are many other examples there, also between African nations and so on, is the infamous political Bermuda Triangle between Cyprus, Greece, and Turkey, which has sunk many a political effort of finding solutions. There's an animosity between Greece and Turkey, particularly after the invasion of part of Cyprus in 1974 by the Turkish protector power. There's an ethnic divide now of the small island into Turkish Cypriots and Greek Cypriots, and this is representative of many other cases that might exist within the GG 2020 network. Okay, so what we propose under GG 2020 is the first research project that includes bicommunal activities. So that would include the Free Southern Greek Cypriot Republic and the Turkish Cypriot community on the northern side. Now that sounds kind of like a logical thing to do because it includes the fine mapping of mutations for hemoglobinopathy genes in Cyprus, Greece, and Turkey, which is of course squarely within the remit of Global 2020. But it is not easy because it's actually societally and politically very difficult in Cyprus to do this. So we need formal international endorsement to achieve this, and maybe by funding, or maybe by formal agreements with external bodies, because these kinds of activities are highly controversial. If as a Greek Cypriot or as a German who works in the Greek part of Cyprus, you're in employment with a Greek Cypriot institution, and then have official interaction with people in the northern part of Cyprus, then that is really frowned upon. And I'm phrasing this all carefully because I still want to have a job when I get back. But basically, shared activities might justify the illegal regime in the north. So we want and we need collaboration with the north, but actually to do this officially is very difficult. Okay, so these bicommunal activities are required in order to harmonize data-guided care provision for all Cypriots on both sides of the divide, and also to allow infrastructure development in the north, particularly electronic infrastructure development. And these collaborations in practice, however, are difficult. And so we need outside influence and international backing to actually push this ahead. So the first part of the talk was basically about science kind of for diplomacy, and in this case it would be diplomacy for science to make this possible. Now to sum up, shared hemoglobin databases build bridges. Okay, they help provide critical community resource. They help link clinicians, overcome societal and political constraints, and to catalyze infrastructural change. And of course, at the end of it all, they promote local autonomy, which enables a reduction of patient suffering and a reduction of carrier efflux to other countries. Okay, this would not have been possible without my head of lab, Marina Kleanthous, and Petros Kondouris, who's a major database developer and content developers, as well as the folks from GG 2020, Helen Robinson, Professor Falil, and Raj, and our collaborators and patients. And thank you for your patience.
Thank you, Karsten. This is very interesting because the program looks at the science diplomacy from various sides. So it's very big potential. The example of Cyprus is very, very interesting, and I hope we all keep our jobs after this. We have time for one question, if you have any specific question now, or we will have a discussion afterwards. Yes, please. There are mics.
How did you foster a collaboration among different countries? Because it seems like there are
So for the initial Ethernet project, it was a formal network funded by the European Union. So we had collaborators from publications who identified people who would be suitable. We contacted them in person, and then in general assembly meetings, you get them together and then you forge out plans. Now for Globalglobin, it's much more difficult because there's no formal funding. As you might know from your own work, if there's no clear deadline and there's no budget, it doesn't happen. Okay, but it's being pushed by HVP from Australia. So Helen Robinson is making a tremendous effort there to move the project ahead, despite the absence of budget and really outside hard deadlines. And we identify from our network of collaborators, suitable collaborators in those countries, and where this doesn't exist, we look at the literature and see who might be suitable, and then we invite them to join us. And because there's no funding at the moment, it disadvantages low and middle income countries because they will not have the opportunity to come to Paris from Thailand, for example, easily, or from other countries without dedicated budget. But we're trying to achieve funding through grant applications, sideways grant applications supported by Globalglobin 2020 and HVP, with letters of support, which would then partially support these network activities. So it's not straightforward to find those collaborators. It's a growth of the network. Yeah.
Another question regarding the databases. Do you have information just on the patient diagnosis, or do you have like an active surveillance system of follow-up of the cases?
Okay, so in the database, there's also data over time, because many of these analyses of patients are done over time. The public database in Ethernet that I've shown you is static, as it is at present. So it gives you disease severity based on mutations and mutation combinations. And it's also not individual patients, okay, because you can then identify those patients, which of course has huge legal and ethics implications. But what we are collecting under Globalglobin 2020, and that's now getting started, is also individual data, which are, however, under lock and key. So it will be displayed to the public, will be summary data as soon as there's more than 2 or 3 patients that can be summarized to prevent identification. Yeah.
Thank you, Karsten. Thank you very much.
Thank you.
While Aaron is coming up, I briefly introduce him. He is a professor of geography at the College of Earth, Ocean, and Atmospheric Sciences at Oregon State University. His research and teaching focus is on the interaction between water science and water policy, particularly as related to conflict prevention and resolution, so science diplomacy, we would say. He has acted as consultant to the U.S. Department of State, the U.S. Agency for International Development, the World Bank, and several governments on various aspects of transboundary water resources and dispute resolution. He's also a trained mediator facilitator and directs the program in water conflict management and transformation, through which he has offered workshops, facilitation, and mediation in basins throughout the world.
Good.
Aaron,
Thank you. So I'm fully cognizant. How many professors do we have here? No, a couple. Okay, so we know what this time period is on campus. This is a death time. And so the window that Karsten talked about where people are still awake after lunch, I know we've passed that window, and so feel free, go ahead and take a nap. I may also. So I hope you heard in this kind introduction the both sides, the science for diplomacy and the diplomacy for science. Our program is about doing that. It's about resolving water conflicts. And to do that, we had to understand water conflicts to begin with. So this is kind of the problematique of international water conflicts. How many water people here? None. So I will give you quickly Transboundary Waters 101. The world on the left is the way water people see the world, through watersheds. Everything's connected to everything else. Surface water, groundwater, quality, quantity, everything's connected. Politicians ignore these lines entirely and draw nice straight lines right in the middle of them. So the world on the left is the world the way the rest of the world, the way you all see the world, is through countries, through economic activity, through ethnic groups. And the problem in water, in transboundary waters, is we have to manage the water as if the world looked the way it does on the left, recognizing fully the problems of the lines and the legitimacy that the lines provide. So in the early 90s, when I started to get involved with this, it was a time of what they called environmental security. And the types of examples that were being raised in this problem were countries like India and Pakistan who share a basin and have fought wars. Iraq, Iran, and Turkey share the Tigris-Euphrates. Armies have been mobilized, shots have been fired. The Nile Basin, 11 countries share the river. At the time in the early 90s, and still, there was a lot of tension between Ethiopian development upstream and downstream Egypt that had been relying on the water since time immemorial. The Jordan Basin, of course, we heard a little bit, as you said, interesting dinner conversations. That's one way to describe relations between Arabs and Israelis, interesting dinner conversations. The relations aren't collaborative, shall we say. And they share a river, and they ran out of water in 1970. So this is kind of the problem. These people who really dislike each other intently generally share rivers, and as we develop increasingly, these problems become apparent. The Aral Basin, for example, dams going up in the upstream countries, Kyrgyzstan and Tajikistan, downstream Uzbekistan and Kazakhstan have been relying on the water. So Kofi Annan, as late as 2001, said this: fierce competition for fresh water may well become a source of conflict and wars in the future. Just curious, how many people agree with this statement, are comfortable with this statement? Okay. Right? It's a compelling argument. We need water for everything. We rely on it for our lives, our livelihoods, everything we do in society. We're running out. We hate each other. Therefore, we're going to go to war. It's an interesting projection. I was trained as a groundwater hydrologist, and what I asked is the normal scientific question: what do we know? What evidence is this prognosis based on? And at the time, all we had were those 6 kind of anecdotal case studies. And so we started to do what scientists do. We started to collect stuff, and we compiled a database. And I want to stress here, the point here is on this idea of open, free access. We couldn't have compiled this without people all over the world generously making their data available freely. And I'm grateful that I'm at a state institution where by law, by state of Oregon law, everything I do is public domain. And so I'm very grateful to be able to compile it freely and then make it available freely. And so what we did is we tried to compile all the world's experience in transboundary waters. And it turns out there are a number of water treaties, about 500 water treaties, negotiating notes, and we looked less anecdotally and more systematically at the world of transboundary waters. And the world is bigger than those 6 anecdotes. The world is actually about 309 transboundary basins, about half the land surface of the Earth. My university in Oregon is in a transboundary basin, the Columbia Basin. Most of you are probably from transboundary basins. So the world is a lot bigger than these 6 anecdotes. And so it started to get us interested. And of course, in parallel, UNESCO has been leading an effort to do the same with groundwater bodies, and they're up to about 700 transboundary aquifers, complicating these efforts. One of the things that we tried to do is systematically look in the last 60 years, not just at those 6 case studies, but at everything that countries have done to each other or with each other around transboundary water, not just on the conflict side, but along a whole spectrum from conflict to cooperation. We compiled these data. It's 1,800 data points. And we found something that helped inform, I think, a period of diplomacy, that most of the time we do anything on water, it's cooperate. So that's this left side of the spectrum, this cooperation here. Two-thirds of the time we do anything, we cooperate. That's Arabs and Israelis, Indians and Pakistanis, Azeris and Armenians. When there's stress, it does induce a period of conflict, but then it also induces all the things we need for cooperation. It induces political will, it induces resources, it induces human creativity. And on the conflict side, here about 80% of conflict is verbal conflict. So what's that mean? Who gets excited about the potential for conflict? You can tell right now in our presidential elections. It's politicians and it's journalists. That's who's driving the dialogue on impending conflict. So when people are talking about war, it's generally one of those 2 groups of people. And actual violence over 60 years, very, very little. 38 cases, 27 of these were between Israelis and Arabs, which is interesting because the last shot fired across a border over water in the Jordan Basin was in 1970. Remember, they ran out of water in 1968, and there's been no shortage of tension since then, but in the absence of violence over water. In terms of war, this -7 there on the left, there hasn't been a war over water in 4,500 years, and there was only one between the city-states of Lagash and Umma that then led to the first water treaty in history. It hangs in the Louvre today. This led to another question. So we started to get interested in what the actual dynamics on transboundary water is. We got that it leads to tension, and we got that the tension often leads to reconciliation, but that period of tension is really, really critical for the diplomatic corps. And so a group in Washington came to us and we said, can you be predictive? Can you tell us where the tensions are going to be in the next 3 to 5 years? And so we did, again, what scientists do. We sat around, we brainstormed, what do we think? Is it shortage? Is it development? Is it water quality? All these kinds of things. And again, we put a huge database together. It's 100 data layers of GIS, 60 years long, so it's 6,000 layers of data. And the idea in this 3-year project, 2.5 years, was just compiling the information. All this is accessible if you happen to be interested. The beauty of compiling it, once it's there, you just push the button and out come the indicators of conflict. The problem was everything changed. Our base map changed. I was so frustrated that the Soviet Union broke up in the middle of our study. I'm not angry at the Soviet Union, but it messed up all of our base maps, right? Imagine there were all of these in red are the new transboundary basins that resulted simply from the Soviet Union breaking apart. So we assumed once we had all of the data, the funders on the plane, they're coming out to Oregon. We say, yes, we're ready to push the button. We'll be able to show you the indicators of water conflict. He comes, we push the button, and out comes absolute garbage, absolute garbage. Every single indicator looked exactly like this. Any people know statistics here? What's that show? Garbage, right? Absolute garbage. Nothing indicates anything anywhere about water, about anything. That was our finding, which is not helpful for the diplomatic bodies, believe it or not. So we went back and we looked, and just to give you a sense of how little the indicators indicate, we thought government type might have something to do with it. So here's the conflict level of ardent democracies, and here's the conflict level of fascist dictatorships, absolutely identical. We looked at climate. How many people would assume scarcity would have something to do with conflict? Y'all would. I know you're asleep. It doesn't matter. But if you were awake and you raised your... We all do, right? Of course. You're running out of something. It gets scarcer. So we figured climate type might have something to do. The big bars here are good. The small bars are the most conflictive climate, and turned out to be the opposite. The dry climate is actually the most cooperative climate. And this is when our little light bulbs went off, right? Because of course, and a lot of you are starting to nod, or maybe nodding off. I can't see. Of course, scarcity leads to cooperation. In dry climates, people have to deal with dryness. That forces them together, right? So all of a sudden, this made us realize the dynamic was not just on the water and stress side, but there's an institutional capacity dealing with change. And so the relationship, to be able to predict conflict, turns out to be about understanding the system itself, the rate of change in the system, and the institutional capacity to absorb the change. And once we did that, we started to get some understanding. So this is dams. We assume dams cause conflict. So here's dams up here, about the same, basins with a lot of dams, basins with few dams. If you have basins with treaties, the difference goes away. The treaties are the institutional capacity to absorb the change. Basins without treaties, the overall difference is much bigger, and the overall conflict level is higher. So it's not dams that cause conflict, it's dams in the absence of a treaty about what to do with the dam. This is how we now understand to see the world. And so with that, we're able to understand the indicators are about unilateral development, or about basins where the institutions break apart, sudden changes, not the normal scientific changes that we were accustomed to looking at. And now we could come up with a map. And fortunately, this map of basins at risk is no longer basins at risk, because then diplomats took this and did what they do really, really well, which was to create the institutional capacity. All of these basins started to have initiatives around crafting river basin organizations, crafting cooperative development structures, crafting cooperative databases where the institutional capacity would grow so the likelihood of conflict would drop. Now here's something interesting about working with diplomats is this is the way we published our map out of Oregon State University, and this is the way the UN, I shouldn't say, this is the way a system that is international that unites nations, let's say that, an institution that unites nations. This is the way the UN published it. So I don't know if you can see the difference. For one, you have the cartographers in the audience. So this is called the stoplight scheme, reds and yellows light, danger, right? So the UN didn't like that. So they changed it to this grapevine scheme, which is kind of grays and browns and greens. But more critically, this was our title. Take a look at their title. There's no conflict in the UN system, right? So now we have not only the basins that we identify at risk, and now, joking aside, UNESCO has been phenomenal about not only helping support the database, but then doing what you need to do in these basins, implementing the diplomacy to get us going. So now with these monitoring, now we know how to monitor for these basins, and we can continue to do it. So we did a global data set of all of the treaties in the world, how well or poorly they function, and that gives us a sense of the institutional capacity. Then you can superimpose on the dams. Fortunately, dams, if you really want to build one, you put a tender out to build the dam, and that gives us about 3 to 5 years to identify the basins at risk. We put this map out now about every 6 months, and so what I want to stress is not just that it's available, because science by itself doesn't lead to diplomacy. It's the diplomatic corps picking up the science and doing something with it. So we took this hypothesis that all of these changes in a system lead to cross-border violence and war, and I don't think it does. Instead, what it offers us is an alternative for opportunity for environmental peacemaking. Where we see these stresses is a great opportunity to get at least the water community together, which then can spread out. And so we've been doing this also with UNESCO. The Aral is a great basin. We just did a lot of work with UNESCO in the basin. So again, the upstream countries are building dams. Downstream countries don't like it. In fact, Uzbekistan said to Tajikistan, if you build this dam, we will go to war over the dam. We end up doing these workshops where, one, we try and get an understanding of what the actual impacts are, but again, you have to get the scientists and the diplomats in the same room to talk about what the creative solutions are. And my experience is the diplomats don't get water, and the water people don't get diplomacy. And there are very few people, and again, I'm grateful for the work we've been doing with UNESCO, because they get it both. They have in their title, science, culture, education. That's exactly what we need when we're doing the work, dealing with small-scale farmers, the lessons that they can teach us from the Fergana Valley that then help the diplomats at the international level understand how they might be able to cooperate over the resource. Notice there's this little country down here, which is also riparian to the Aral Basin, and that leads also to a lot of I'm going to go for two more minutes. The Afghanistan is 100% transboundary basins. You do anything in Afghanistan, you're going to affect another country. If you've been following the news, you know the U.S. has a presence in Afghanistan, would like to help stand up the country economically, which a lot of times means water resources development, which means impacting your downstream neighbors, which are whom? Iran, Pakistan, Turkmenistan. So there's a lot of sensitivity to what's going on, but it gives us, again, entree to have conversations between, for example, Afghanistan and Iran, Afghanistan and Pakistan, or more to the point, all of them in the room together, and some of that's going on behind the scenes. I just want to give this one last example because I think it's important to understand when we're dealing with databases and people who don't like each other that there are ways to craft ways through to exactly to your question about how do you build the database. One of the projects was on the Kura Arax. This is shared between Armenia, Azerbaijan, and Georgia. Armenia and Azerbaijan don't have relations, don't have anything to do with each other in public. They both have relations with Georgia. They have a huge water quality issue left vestige from the Soviet Union, and the water people got together and said to their political people, you gotta let us get together to talk about the water problems because we can't address our environmental hotspots unless we understand. We have to get together. They allowed these meetings to happen in secret a number of years ago. There's a huge amount of tensions, actually, people outside the hotel trying to get in to get one of the delegations to bring them out and do them harm. The problem is you have all of this data, and you can't share it in any way that would ever be seen by the outsiders sharing data, just like you were talking about Turkey and Greece and Cyprus. So the trick was here, they developed a process called parallel bilateralism. So Azerbaijan and Georgia developed a database, Armenia and Georgia developed a database. They agreed that the databases would be compatible. They shipped both databases off to a university, which I won't name, that's out on the West Coast in a beautiful state north of California. And there it was merged together. The hotspots were identified. The hotspots themselves go back. People can do the planning based on these hotspots without ever seeing that the data were merged. Kofi Annan, who predicted war, ended up with this. Water problems of our world need not only be a source of tension, they can also be a catalyst for cooperation. If we work together, a secure and sustainable water future can be ours. Thank you.
Thank you. Thank you, Aaron. I think you convinced me. I don't know the rest of you, but it's very, very convincing. Thank you very much. We have a few minutes for questions if there are specific questions that you want to pose to Aaron. No? So either you were very clear or you were right on the NAP issue. Okay. Paula Dunbar, I didn't ask you. How do you pronounce it? Dunbar. Is a physical scientist of NOAA's National Center for Environmental Information and the ICSU World Data Service for Geophysics. She works with natural hazards data and information and manages the distribution and archive of the global historical tsunami event, significant earthquake, and significant volcanic eruptions databases. Ms. Dunbar has developed web-based educational tools such as an online kids hazard quiz and interactive maps. She works closely with the UNESCO IOC NOAA International Tsunami Information Center to develop tsunami education and outreach tools. She is particularly interested in the use of historical tsunami event data for tsunami hazard and risk assessment and mitigation. And I think we'll hear of that now. Thank you.
Thank you, Ernesto, and thank you, UNESCO, for inviting me. Okay, I'm going to briefly introduce tsunamis since 2004. I don't think there's anyone that doesn't know about tsunamis. Who we are at NOAA, some of our data, tsunami data, and a few significant tsunamis so that you can understand the history of the warning systems and how we fit into that, and then how we support the system. So tsunamis are a dangerous flooding hazard. They're created by an abrupt disturbance of the ocean, either by earthquakes, volcanoes, landslides, or meteors. They can spread throughout the ocean and deliver death and destruction to coastal inhabitants thousands of kilometers from the source. So in 1965, the UN, through the IOC UNESCO, formed the International Coordination Group for the Tsunami Warning System in the Pacific to provide education and warning to Pacific nations. And I'll get into why that happened in '65. Today, most coastlines of the globe are part of the system, the Global Tsunami Warning System. Tsunami has arguably been the only natural disaster that has been addressed so effectively at an international scale. And I think my story will explain that. So we're part of NOAA, the National Centers for Environmental Information. Probably no one here has ever heard of the National Geophysical Data Center, but that's what we were formerly known as. We provide long-term archive data management and access to global tsunami data. And I'm going to get into the specifics of the data types. What I'm mostly involved in is the historical tsunami data. If we know the past, we can better understand the future. It's a scientifically curated list of historical tsunami source events and water height locations throughout the world, and they range in date from 2000 BC to the present. The data supports operations and mitigation. Tsunami warning centers use the historical data in decision-making, helps them determine whether they're going to, in a particular event, do a watch, a warning, suggest an evacuation, and it's also helpful to respond to the media to explain what's happened in the past in certain regions. And it's also very helpful for tsunami hazard assessment and for developing inundation and evacuation maps and plans. It also supports research. Scientists create models that forecast what a tsunami will do in a certain event, and they look at events in the past to compare their output to validate their models. It's also it's useful for land use and codes and engineering criteria, and particularly for education to help the public understand where and how often events have occurred. This image here is Rick Bailey from Australia, one of our colleagues from the Australian Tsunami Warning Center. He's pointing at a map that we developed. We work a lot with the IOC UNESCO International Tsunami Information Center to develop educational tools using our data. There are over 3,000 documents that have been used to compile information on tsunamis. We use information not only from tsunamis, but earthquakes and volcano catalogs, because they can generate tsunamis. The oldest document that we know of, there was a cuneiform tablet that described a tsunami in Syria in 2000 BC. There's some disagreement about what the actual date was, but obviously a BC event. So we use just about everything that we can compile information from newspaper reports. The tsunami warning centers give us data, USGS. We work a lot with the International Tsunami Information Center. We look at web articles, emails, and then an important input to the data are the International Tsunami Survey teams. The first survey by an ITST was in 1992 in Nicaragua. Since then, there have been more than 34. There were surveys prior to that time, but they hadn't been officially called an ITST. And of course, the idea is we have local teams working with international scientists to do the survey, helps us understand tsunamis, develop tools and programs to mitigate the effects. So once a field survey is completed in a country, a summary is provided to the officials so they have a better understanding of what happened in their country. And during the survey, the scientists train the local scientists so in the future they can do their own surveys. Our database is a trusted data source, and we've been cited many times from things such as Science Magazine to National Geographic. It's important when users use the database that they understand the limitations and what is actually covered, because historical data can only be collected if there was a written record. We do have paleo data, but we don't include that in the historical. And it's important that we collaborate internationally. I'm just going to give you a couple of examples of how important this is. If you live on the US northwest coast, you've probably heard of this. In 1700, there was a tsunami in Japan. It was known historically. They wrote it up, documented it. There was deaths and damage in Japan, but there was no known earthquake, and they understood that earthquakes generate tsunamis. The weather was quiet, so it wasn't a weather event. So they assumed it was a far-field event. But for hundreds of years, it was called the orphan tsunami because they didn't know what the source was. So in the US, on the West Coast in the 1980s, scientists began to look at the paleo record because they thought there probably had been a large earthquake generated off the coast from the Cascadia subduction zone. So in the 80s, they did determine that there had been an event, and through radiocarbon dating and tree ring dating, they determined that it was around 1700, plus or minus 10 to 20 years. So from conference presentations from the Japanese, presentations by US seismologists and the tsunami scientists, because they also were pretty sure they were seeing tsunami layers, they began to realize they were talking about the same event. So in 1996, it was the first confirmation that a Cascadia earthquake, probably a magnitude 9 at least, was the source of the 1700 Japanese tsunami. This is another case, the 52 earthquake and tsunami in Kamchatka, is another case where the written record as well as international collaboration spread new light on an event. In 1952, there was a large earthquake in 9.0. It was known that there were a few deaths in the Kurils. There was damage in Hawaii, but that's all that was known. And for such a large event, it didn't seem like the real picture was available. Turns out it was a closely guarded state secret. And until the fall of the Soviet Union in 1991, no one knew how damaging it actually had been. So in 2003, excuse me, some articles came out from Russia that told about the fact that the tsunami had eradicated the naval base at Severo in the Kurils, and probably 10 to 17,000 people died in that one event. I'm not going to get into this, but this just shows you the completeness of the Pacific catalogs. This is a plot of all of the tsunami sources in our database. As I mentioned, it starts from 2000 BC to the present, has the typical information, date, location, magnitude, cause. Also includes socioeconomic data, which is where the written record becomes really important because we include information such as deaths and damage. We have a list of references. There's about 1,000 confirmed. We assign a validity because some of the, especially the older events, were not absolutely certain it was a tsunami, and there's about 1,200 unconfirmed. Each event has an associated wave height, either from 1 to like 6,000 from the 2011 Japan event. Has similar information, but it's specific for that particular location, such as the wave arrival time, height, and we also have a list of references. There's about 25,000 wave height observations in the database. So when people are looking at tsunamis, one of the first things they ask is, what were the biggest? This is a plot of the top 10 by deaths. Starts with the Philippines, a local event in '76 with 6,800 deaths. Then it jumps to the 2004 event, the devastating 230,000 deaths throughout the Indian Ocean in 15 countries, including Indonesia and clear over to South Africa. Just to put it in perspective, there was an earthquake in China in 1556 with 830,000 deaths, and then the 2010 Haiti earthquake had 310,000 deaths. Then again, what were the most damaging? And this information is converted to today's dollars. Again, the first on the list is in the Philippines, and then we jump clear to the 2011, the devastating tsunami in Japan that cost between $200 and $300 billion. It's still considered the most expensive natural disaster that's ever occurred, and as you probably know, it also included a nuclear accident. So a third way that people look at tsunamis, and one of the most important for international collaboration, is what tsunamis have occurred in a local area but caused effects in the far field. We call those teletsunamis. And that means that there are effects at least 1,000 kilometers or 3 or more hours from the source. So this is a list of tsunamis that not only caused effects, but they caused deaths in the far field. And I'm going to specifically talk about 3 events that have affected policy. That was the 46, 60, and then the 2004. So in 1946, there was an earthquake in southern Alaska, 8.6. It did cause local effects, deaths, and damage, but then several hours later, 4 to 5 hours later in Hawaii, there were 159 deaths. There was also a death in California. You come clear down here to French Polynesia. I think it was 9 hours later, there were 2 deaths. And then clear over in South America, in Peru, there was 1 death. And then there was also damage in New Zealand. So because of this event, in 1948, the US established the US Seismic Sea Wave Warning System. The idea of that system was just to warn Hawaii, because Hawaii is sitting in the crosshairs of subduction zone all around the Pacific. It started out with just 3 seismograph stations and 9 tide gauge stations reporting. Also following this event, in 1952, Japan established their own National Tsunami Warning Center. And then in 1957, Russia established tsunami warning centers on their far east coast. That was really a result of the 52 event that we talked about previously. So then the next, probably one of the most important events, do I just have 2 minutes? Yeah. Okay, all right. Was the 1960 event in Chile. It was a 9.5, caused local deaths, and then again, caused deaths in Hawaii, California. A day later, from the source of the event, there were deaths in Japan, and more than a day later, deaths in the Philippines. First, Chile then established their warning center, and then the IOC asked the US Coast and Geodetic Survey to organize a meeting of countries to develop a tsunami warning system for the Pacific. So this happened in '65 in Honolulu. There were 12 countries and several international organizations. So we had already established the warning center in Honolulu for the US. They offered that center as the new Pacific Center, and it's now called Pacific Tsunami Warning Center. And it continued operating. Every 2 years, IOC organized meetings of the countries involved. And then last year, we celebrated the 50th anniversary. So that continued the only system within the globe until the 2004 Indonesian event. As I mentioned, there were deaths in 15 countries. And so today, under the IOC, there are 4 systems. Every coastline of the world that has a tsunami hazard is covered with a warning system. The Caribbean has one, Indian Ocean we talked about, the Northeast Atlantic and Mediterranean, and then the Pacific, which has been operating since '68. I'm going to quickly just talk about, this isn't data that we archive. We archive some of it. Started in '48 with 3. Today there are over 500 seismic stations reporting to the warning centers throughout the world, which enables them to quickly put out messages. Similar situation with the sea level data. In the US, we started with 9 telex messages. The gauges were automated. Then we developed the DARTs, which are deep ocean recording of tsunamis. Today, there are over 500 that report in near real time to the warning centers. So just quickly, we don't archive all that data. We focus on the US, and then in event specific, we archive other nations' data at NCI. We also do event summaries where we pull all the data together so that people can get a snapshot of what happened in a particular event. We also develop DEMs. These are important for every aspect of tsunamis, for warnings, inundation, evacuation maps. We're also starting to train scientists in other countries. And one of the limitations is the data that's available. We've got to have high-resolution data to develop a good inundation model. So just to summarize, the end-to-end warning system, which requires international data gathering and good data at all points. It's based on earthquakes. About 80% of all tsunamis are generated by earthquakes. The earthquake happens, the warning center uses data from all over the world to locate it, look at the historical data, decide whether they are going to put out an amplitude forecast. The country or the local level gets that information, determines are they going to issue an evacuation, and then the people need to understand at the local level when they get the evacuation, where do they go? They need evacuation maps and plans. They need to know what to do in case of this. So again, the data and diplomacy improve all aspects of the system, and ultimately the goal is to save lives. So I'm just going to quickly say that we're continuing to update the data, steward the water level, develop DEMs. We're constantly looking for partners to improve the data and the products. And future concerns are looking to the tsunami currents to better understand the effects of the tsunami, to better understand landside tsunami sources, meteo tsunamis, which I didn't talk about, and just all the different ways that scientists look at hazard assessments. Thank you.
Thank you. Quite impressive to have a database from 2000 BC to today. Thank you very much. Any questions to either to Paula, or we just go to the whole panel? Any direct questions to Paula? No? So, yeah, Karsten.
How do you get the response harmonized? I mean, you showed those posters for information. So how do you get the information from those stations that receive information that tsunami is coming up within 1 or 2 hours to the guy on the beach with a bathing suit looking at the wave threat?
That's actually not my problem, but it is a problem. Yeah. Actually, I think Aaron can talk about it more. He's from Oregon. There's different methods. They have sirens, reverse 911. Do you have any other?
Well, for us, the warning is the earthquake itself.
Oh, yeah, of course, yes. Yeah. Yeah, so that's education to understand if you're in the local area, you feel an earthquake. There's also discussion of if you see something unusual in the sea, just evacuate.
I was thinking about this issue of shared databases are means and ends, no? Yeah, please. I think we can have a 10 minutes or 15 minutes discussion. We lead a little bit into the coffee break, but we started a little bit late too. So, colonizing the whole. I want to ask something to the three of you to see who wants to react, but really, it seems that the collaboration on databases are some kind of virtuous cycles, no? Where the more partners you get, the more it fills the needs and really delivers. But how do you start? What is the beginning? What was the beginning in your cases, and how would you do that differently, or would you suggest in terms of how do you start the virtuous circle to flow?
Ladies first, maybe. So.
Okay, I wasn't involved in the beginning of this, but I can tell you the history. The first tsunami catalogs, I think the first one was in 1947. Basically, a scientist just took all the earthquake catalogs and pulled out tsunamis. And then Hawaii was probably the next, Japanese and the Chinese have long histories of cataloging earthquakes, which include tsunamis. I would say the internet is partly where we really began to collaborate, because we put information on the web and then people would see it and they would want their information included. Just going to meetings and talking to people.
So from our end, as I said, it's my fortune to be at a public university, a land-grant university, so everything we do has to be public domain. And that means that I have to start on the right foot. And so once we start collecting something and making it available online in real time, you get that reputation. And my experience in the data world is the data world's kind of divided into three. There's the like you said, the altruistic folks who realize that we have to share the data in order to get good stuff done. They're the data hogs who generally do, my experience is generally do mediocre work and don't want to let the data out so people notice that it's mediocre work. And then there's the private sector that are holding on to it for profit. And so the people who are generous just are creating their own community, and it's a self-reinforcing cycle is my experience.
Well, for us it was because of our laboratory work, basically, because we're a diagnostic lab, and we wanted to find out with our collaborators, how we could improve things, how we could improve, for example, prediction of pregnancies. So if two people come together that have different mutations, that baby, if both mutations are inherited, how severe will the disease be? And those data were not out there. Of course, that was in somebody's filing cabinet, somewhere on paper. So it was a need to kind of digitize those data and to combine those data to make them available as a resource that started the whole thing. And at the time, the database that was available, it was very traditional. I mean, it was only a list of mutations from static records. And what really is at the crux of this, but it was now under development also for Globalglobin 2020, is this genotype-phenotype correlation. So you know what the patient genotype looks like, and then you can extrapolate what likely disease severity you will have. So it was a practical need that kind of got us into this. And now it's a development in its own right, because it builds up, as you said.
Thank you. We have a question here.
Hi, my name is Beth Zittler, and I work as a AAAS fellow for the Millennium Challenge Corporation. We're a very small U.S. government foreign assistance agency. And my question is actually for all three of you, because I think all three of your databases have real implications for folks who live in lower income and lower middle income countries. And I was particularly noticing when you showed some of the mutations, several of them were named for places, like one was called Ziguinchor or something, which is a place in Senegal. And it's a place where we've rehabilitated road. But my point is to ask you, when you're working with folks in low resource areas, either researchers or I'm sure you work with governments on some of the more policy-oriented stuff, but maybe even the public, if you have had those interactions. When people are coming to you to ask to use your database or to ask questions about your database, what kinds of barriers they see to using the database that you guys have developed?
Let me start, so I'm not always at an advantage for having longer to think about the answer. So for us, the problem is often in those under-resourced countries that they're paper records. That's one thing, so it needs to become digital first. These are patient records, and many African countries do not have a central computer system to store those data, far from it. So that's the one major problem of getting the data digital first. And then there's other problems which are, for example, the release of the data is difficult because it's personal information. Mm-hmm. You'll be more aware of this in the States than anywhere else because it is an insurance issue and it might really affect your insurability in future and so on. So those kinds of issues. Because we search out the collaborators and particularly for Globalglobin, we try to build up the infrastructure that is not currently there. It's not a problem, it's actually part of what we want to resolve. It's part of the effort of the project to do this. So it's an aim of the project to achieve this digitization and building up the infrastructure.
Well, it's something that I've always been cognizant of, so I've always instructed whoever's working on the database to make sure it's accessible for the slowest possible connection. So in the day, whatever, dial up with 386 or whatever. That's been critical. But the other thing is the output. Anything that we do, any publications are all available online. And back before that, you could do that readily. A number of the publications, for example, that we did, we collaborated with UNESCO to do a textbook on training in water conflict management. And they offered, because it was through UNESCO, it was Cambridge University Press, but they offered the option for the authors to forego royalties in exchange for making it free or very, very low cost in the developing world. And all the authors agreed to do that. So it's something we're really, really cognizant of and try and make this stuff accessible and available.
Ours is similar. All our data is publicly available. In the underdeveloped world, one of the problems is just having the historic data is not always available. But we also work, excuse me, with the International Tsunami Information Center, an IOC, UNESCO, NOAA. It's a partnership, and they do a lot of training throughout the world. So they take our data and they distribute it as posters, et cetera. So that's kind of how we get it out to other countries.
Can I follow up on her question? I was curious about your database. Do you include kind of oral records and indigenous? I know in the West there are a lot of legends about the waves and the earth shaking and so on.
We actually, the 1700 is a good example of that. There are traditions that don't pinpoint the exact date, but are probably describing the 1700 event. So we include information about that, but unless we can get a date, we don't include it. There might be comments about something like that related to an event that we know about.
Just to add briefly, of course, in our case, often the data first has to be created. So particularly the new partners now in Globalglobin 2020, they first have to take in the patients and do the sequencing. So that's the first step that is actually has to be performed before data at all exists. So it's even further back. So for those low resource countries, that's a preliminary step for that.
Yes, please.
Hi, my name is Brian Wee with a private consultancy called Massive Connections. My question is regarding public-private partnerships or things along those lines. Now, so the question is, given that there are infrastructure costs for maintaining data in the long term, what have you run across in terms of getting the private sector to contribute to the long-term maintenance of the upkeep of such data, and also to contribute to maybe future efforts to improve the data in terms of more data collection? And the reason why I raise this, of course, in the U.S., as Paula knows, we have the NOAA has put out a crater where you have Google and the other various big players, public sector, private sector players come in to use NOAA data, and the objective is to demonstrate a public good that can come out of the private use of public data. And so the idea is that there must be some way by which you can think of using private sector contributions to improve and maintain the data. So what thoughts have you had with this regards on an international scale?
So luckily for us, it's so the database development is low resource because we now have a single person doing the database, and we have got one person for the content development basically. But we have thought about this in the past, and one way in which we've added content was we contacted one of the diagnostic companies that produce those machines for detection of variants of hemoglobin, Biorad. And they've actually provided us with the data they had compiled at the time of 650 different variants. So we have the images and the data for those now in the database. They granted us this, and we had to put a disclaimer in that if used for diagnostic use and so on, there's no liability by Biorad for any ill done, obviously. But so that's one thing. So we get data from companies because, of course, if the data are available, it makes it more likely people will go to their machines to use them because as a resource for diagnosis. Now, because the Ethernet portal is kind of ready for the public, and now it's used more and more, we have thought about also putting on sponsors, the obvious way of doing it. One problem there is that, for example, in collaboration with the Human Variome project, you must not collaborate with a single or with a particular sponsor that then seems to be directly linked to HVP because it wants to maintain its neutrality for this. But because I have to admit, I'm so tied up with lab work most of the time, or with writing grants and so on as we do, that we haven't thought enough about this. It's actually money that could be made available for someone working additionally on the database, but we haven't put the effort in. It's good you mentioned it.
Yeah, I'd love to hear your thoughts, because this is exactly our quandary, is getting research money just to update or maintain a database is next to impossible. It's not easy to do. And we've been approached a couple of times by private sector folks who've been interested, but then they want to make it private and charge for it, which is counter to everything that we do. So if you have thoughts on how to get around that, I'd love to hear them.
I was just going to mention that we kind of do the reverse. We go and look for everywhere that we can see somebody commercially is using our data as justification to continue getting government funding. I just was going to point out something that's interesting in the tsunami world that went from government to private. I don't know how familiar you are with the DARTs, the Deep Ocean Assessment and Reporting of Tsunamis. These are buoys that are measuring the water height in the deep ocean. There's about 40 or 50 deployed around the world. Gives us indication after a tsunami has occurred of what the height is before it reaches the coast. It was developed by NOAA scientists at the Pacific Marine Environmental Laboratory, and now there are commercial companies such as SEIC who are developing them and providing them. So it's good for the commercial world, I guess.
Thank you. Any other question? Yes, please. Last question, so please. Because we're hearing everyone else having fun outside.
Hi, my name is Apurva Dave. I'm a AAAS fellow at EPA and an oceanographer. So the question I guess I have is for the entire panel, using a specific example from oceanography. So one of the databases or tools that's available or that has recently become available to oceanographers to monitor earthquake threats and tsunami threats in the global ocean is the network of underwater sensors that are employed by the CTBTO, or the Tasmanian Treaty Organization. And this is a formal database that was developed and employed for another, set of processes and another purpose. And there was a point at which the oceanographic community and I guess the security community, their conversations or their thoughts intersected, and this device or this set of data and this tool for achieving information or arriving at information about these threats became available. And I'm not exactly sure what exactly happened to it, but my question to all three of you is, there are instances where there are formally developed databases and information gathering networks that are developed for completely different purposes that become available to other communities of scientists. And it's not clear to me exactly how those intersections or that awareness occurs. Is it just happenstance, or are there formal mechanisms that you're aware of or that maybe you're trying to help develop to kind of encourage those types of cross-disciplinary discussions?
I think what you're talking about is seismic data. I don't think it's deep ocean data. It's the seismographic data. And what had to be shown to them was life safety, that if they had that information, they could locate earthquakes faster, they could determine the possibility of a tsunami. So it was purely, if you don't provide this, people will lose their lives. So it was life safety that finally convinced them to open that data up. I'm pretty sure that's what you're talking about, because it was right after the Indian Ocean. There was a lot of looking at all kinds of data sources.
Yeah,
I think
from our end, it's serendipity more than anything else. I mean, we know what we need to do some analysis, and then we'll go out specifically looking for it. But I was just at another meeting yesterday, and there were people it was interesting, there was a panel like this, 3 different US agencies were all doing very, very similar modeling, trying to do some predictive capacity, and they didn't know that each other was doing basically the same thing. And who've been in this world for now 25 years, I didn't know any of them was doing any of it. So I think the data, my experience is the data is generally easy to find, but people's integration of them and analysis of them is much more complicated and often much more useful. Yeah.
So in our case, we were going for the big databases. So we looked at what was available at Ensemble, NCBI, and at UCSC, the genome server. And then we, for example, for the one tool we use, it's this NIH-funded NCBI genome server that we've integrated into the website, because it's a good tool it's used by everyone. Long-term maintenance is assured, and so on. For early development of the database and the interface, we looked for publications on different tools, but by the time they're published, they're often already obsolete. And of course, then you might then have long-term maintenance of them, so it's tricky. You look through the literature, but yeah, you find out what you want, and then you look for tools you think will have long-term life for implementation. Yeah.
Okay, thank you very much.
Thank you
Thanks.
very much.
This was a very good panel.